Well, folks, this is kind of crazy. This hasn't gotten that much attention in the global news, but there was a massive eruption at a volcano I'd never heard of called Hayli Gubbi shield volcano in Ethiopia's arid northeast. It's long thought to be dormant, but it sent ash 9 miles into the sky in an eruption on Sunday, November 23rd. The eruption occurred at 8:30 UTC, and this area is just not known for this type of eruption. Usually there is a more longer term, slower eruption going on at the neighboring volcano of Erupted. In this video, we're going to take a look at some of the satellite imagery. We will look at the Sentinel-2. We've got some precursor stuff in the crater before the volcano that occurred, as well as a massive deposition and a huge two massive plumes going in different directions. We'll be explaining all of this coming up. So apparently, up until November of this year, there's been no known record of any eruptions at this volcano within the past 12,000 years, since the beginning of the Holocene era. However, there may have been more recent eruptions that were not recorded, or which there is not enough evidence of yet. Hayli Gubbi, I think it's pronounced, it's a shield volcano similar to Mauna Loa in Hawaii. It's located in the Afar region of Ethiopia with an elevation of around 500 meters on the southern end of the Erupted range, which is a whole line of volcanoes which sit in the East African Rift Zone. This is a region where the African and Arabian plates are pulling apart at about a rate of 0.4 to 0.6 inches a year. Erupted is to the north, and that's been active in recent years. In fact, we've watched it over the years with big lava flows over the decades, has spewed long lava flows that actually went a long way away from the volcano. However, we haven't seen anything like this type of explosive Plinian type eruption that we've seen with this case. So some details about the eruption, and now I'm going to be changing some of these details based on what we find. We'll go to our own conclusions, but the initial eruption was reported to have occurred at 0830 UTC. An ash plume reported to 45,000 feet. That's about 14,000 meters. That's what we're going to be checking and going a little different. The ash plume later drifted across the Arabian Peninsula, including over Yemen and Oman, and then it went further afield over Pakistan and into India, causing flight disruptions. The type of eruption is known as subplinian. So I think if it's a Plinian eruption, it means that it's a ejecting column that goes all the way into the stratosphere, whereas this one seems to be primarily a tropospheric eruption, but it went all the way through the troposphere up to the tropopause. And amazingly, one of the super high-resolution planet satellites captured the plume right at the beginning of the eruption in the morning. While this was a very surprising eruption, it didn't come out of completely nowhere. There were some precursor signs that occurred, and we have checked the Sentinel-2 time-lapse. And what you can see is over the course of this year, you start to see a small cloud developing in the actual crater. It kind of looks like fog, but this is quite persistent. The first time it occurs in the Sentinel-2 satellite imagery is back as early as July, and then it just appears again and again. Now, if we check back to 2024, you won't see any evidence of this type of cloud, and it can't be a little fog cloud. It's definitely volcanic in origin. In a way, we're a bit fortunate that this eruption happened this year, because this was the year that RAMMB brought in the new Meteosat 12 satellite imagery, which is more detailed and looks down on this region of the Earth. So we can go run through a few of the images and loops we've created to look at this. The most detailed imagery is from the red band of the visible bands, and this shows the eruption shooting up, the upper plume going out. But if you notice, down below, there's a plume going off towards the top left of the screen. That's a plume moving towards the northwest. So something was going on at lower levels. The elevation of the mountaintop is about 500 meters. This plume was probably in the 500 to 2,000 to 3,000 meter range. We're going to be looking at the winds to see why these plumes were moving in different directions. To get an idea as to how deep the plume was, we can look at the infrared imagery, which shows you the temperature of the cloud tops. In this loop, you'll see it burst up into the reds and even into the dark reds. And on the color scale, that indicates temperatures of the top of the plume getting down to minus 70 or maybe even minus 75 Celsius. So we're going to look at the nearest sounding, and it turns out that during this loop, if you look at the time, it goes past 12 UTC on the 23rd of November, and the plume passes over the southern Arabian Peninsula. There was actually a balloon that was launched at 12 UTC, and we have the sounding data to check it. So I think it may have actually gone up through this plume. This is another one of the bands. This is the shortwave IR, and it actually goes red when it detects a really hot heat signature. And you can see that it did do that just during the beginning part of the eruption, then it dies away and disappears. So the balloon sounding I was mentioning at this place, Abba, this one occurred, as mentioned, there was one at 12 UTC. I'm showing the 0 UTC one before the eruption. I'll show the other one in a moment. So those temperatures of minus 70 are on the diagonal lines at the side. If we go up, we'll have to label it and then draw it on and go up to where the temperature of the atmosphere was actually at that temperature. And if you look at the heights on the left side, actually, this was around 16 kilometers. That's minus 70, and it looked like it got even colder than that. So this is actually a fair bit higher than what the estimates were saying. Of course, this sounding isn't actually directly over the volcano. It's across the Red Sea, so there may be some differences, but the stratosphere, I don't know. At that level, it may not be that different. And this is the sounding at 12 UTC, so this was when it may have gone up through the actual plume itself. I'm not sure, I have to check more thoroughly. You can definitely see those strong winds that were dragging the plume over the Arabian Peninsula and potentially over it. The difference with the 0 UTC sounding is a moistening in this level up here, around the 300 millibar level. That could be an indication that it's going up through the plume. It does get close to saturation, not quite there. So, yeah, definitely requires further investigation. And what about that split plume with the lower plume going towards the northwest, while the other one in the upper troposphere goes towards the northeast? What's going on with that split plume? Well, we can go back in time with Ventru Sky and look at the winds at the different levels. Since we know the plume penetrated the whole troposphere, it interacts with all those different winds. In the lower troposphere, you can see immediately, this is around 2,000 meters. So here you can see there's a fairly shallow region of southeasterly winds, and that seems to explain that surge of volcanic dust that moved towards the northwest very rapidly at lower levels. And then if we move up in the atmosphere at upper levels, you can see there's a large trough in the jet stream over the area at the time, with these southwesterlies on its eastern side, and those winds are the ones that are dragging that plume so rapidly across the Red Sea, over the Arabian Peninsula, and later you can see how that then advects it and stretches it into Pakistan, India, where it caused further problems. By Sunday afternoon, the Aquamodus satellite captured this extraordinary view of the plume in the upper troposphere drifting across the Red Sea and over the Arabian Peninsula. Meanwhile, you can also see that lower plume moving towards the northwest. Now that a few days have passed since the eruption, we have an after image and we have a before image from the high-resolution Sentinel-2 satellite. We can compare these two to see how the differences change. First of all, the first thing we can see is this big, blanketing, vast ash plume that fits with it spreading out from the volcano and then out towards, in a kind of a fan shape, out towards the northwest, which fits with that plume we saw in the Meteosat 12 imagery loops. And the other thing is, if we check out the crater itself, before the eruption, there was only one main vent, but now afterwards, there are two new vents that must have been created during this massive explosion. The other thing we can check is the heat signature after the event. It seems that things had cooled down quite a lot, and it was a very kind of intense but brief eruption. but you can still see a few heat signatures on that second small event and maybe a little off to the side as well. And there was also an expedition by Osman Soratur's Volcano Discovery, associated with Volcano Discovery. They visited the crater and they saw this thick layer of fresh ash that you can see from space from the satellite. And that is about all I have for now on this. Let me know in the comments if you have more information, and please like and subscribe if you enjoyed this video. I'll see you in the next one.